Have you ever, really looked at a golf ball? I mean, picked one up and noticed all those little dimples.
Yeah, they seem pretty simple, right? Just little indentations covering the surface.
Exactly.
Yeah.
But what if I told you those dimples are actually central to modern golf? They're this amazing mix of physics, engineering, tons of research.
It's absolutely true. Most people barely give them a second glance, but those dimples, they're hugely important for how the ball flies after you hit it.
It's this hidden science, really,
Hmm.
affecting distance, how stable it is in the air.
Totally.
And that's what this deep dive is all about today.
Yeah.
We want to unpack the surprising science behind golf ball aerodynamics,
Yeah, figure out how these tiny little features make such a massive difference.
right? How they change the flight, the distance.
Yeah,
It's a real game changer in sports design when you think about it.
definitely.
So let's start right at the beginning. The big question, why do golf balls even have dimples? What's the point?
Okay, well, to get that, you got to understand the basics of aerodynamics in golf first. It's really just the study of how air interacts with the ball when it's flying. And there are two main forces we're talking about: drag and lift.
Drag and lift, right? So drag is the one slowing it down.
Exactly. It's air resistance, like putting your hand out of a car window. That force pushing back, that's drag, working against the ball's motion.
Got it. And lift.
Lift is the upward force. It's what helps the ball stay airborne longer, kind of fighting gravity for a bit.
Okay.
And how the air flows over the ball's surface, that's critical for both these forces. Now, here's the weird part. Think about a golf ball without any dimples, just perfectly smooth.
A smooth ball. Intuitively, you'd think that'd be better, right? Less resistance.
That's what most people assume. But nope. A smooth sphere flying through the air creates this specific kind of airflow where the air peels away from the surface really early on.
Peels away.
Yeah, it separates quickly. Imagine the air just can't stick to the back half of the ball. This creates a big turbulent wake behind it.
Ah, like a vacuum effect.
Sort of, yeah. And that large wake means much, much more drag. So a smooth ball, it just wouldn't fly very far at all. It would drop out of the sky way too soon.
Wow, okay. So the smooth ball is actually the problem here.
Okay.
And the dimples, even though they look like they'd mess up the flow, are the solution.
Exactly. That's the counterintuitive bit. The dimples are there specifically to disrupt that smooth flow.
Disrupted. How does messing it up help?
Well, they create this very thin layer of chaotic, turbulent air right next to the ball's surface. Scientists call it a turbulent boundary layer.
Turbulent sounds bad, though.
Usually, maybe, but here it's exactly what you want. It's like the dimples give the air something rough to hold on to.
Hold on to. Okay, so this turbulent layer, why is that better? What's the magic?
Because that turbulent layer, it sticks to the ball's surface much longer as the air flows around it. It hugs the curve further around the back.
Okay.
And because it stays attached longer, the wake behind the ball, that messy, drag-inducing area, becomes significantly smaller.
So smaller wake means less drag.
Drastically less drag. And at the same time, especially with backspin, the dimples help create an imbalance in air pressure, faster air over the top, which generates lift, pushes the ball upwards.
So less resistance pulling it back, more force pushing it up.
You got it. That's the combo.
And the difference this makes is, well, you said it's huge.
Oh, it's a night and day. A pro hitting a smooth ball might get maybe 130 yards out of it.
130. Okay.
But give them a dimpled ball, same swing, easily 270, 280 yards, sometimes more.
Whoa. More than double the distance.
Yeah, it completely transformed the game. Allows for the kind of power and distance we see today. It's not just a small improvement, it's fundamental.
That's incredible. And the way golfers discovered this wasn't exactly in a high-tech lab, right? The history is pretty cool.
Yeah, it goes way back to the 19th century, and it wasn't planned, really. It was all observational, meaning golfers just noticed something odd. They found that their older, beat-up golf balls, the ones with nicks, cuts, scrapes, actually flew better, farther than brand-new, smooth ones.
Seriously. Their damaged balls worked better. That must have been confusing.
Totally baffling at the time. Imagine paying for a new ball and finding your old, scuffed-up one outperformed it. But it happened often enough that people started paying attention.
The big aha moment, just from playing the game.
Pretty much. And that observation eventually led manufacturers to think, hey, maybe we should intentionally add texture.
So they started roughing them up on purpose.
Kind of. It started with random marks, trying to mimic the effect. This was back in the days of featheries, leather pouches stuffed with wet feathers, and later the gutties made from gutta-percha sap.
Wow, feather balls, okay.
Yeah. So the design evolved from those random marks to the very precise engineered patterns we see today. It was a gradual process driven by noticing what worked on the course.
Which brings us to now. If dimples are so good, and we understand the science better, why isn't there just one perfect dimple pattern everyone uses?
That's a great question. And it really highlights how complex this stuff is. There's no single best pattern because golf balls aren't one size fits all.
Like different golfers, different needs.
Exactly. Every ball is engineered with a specific type of player and a specific performance goal in mind. Are you trying to maximize distance above all else, or do you need more control and spin around the greens?
Like designing a car, you wouldn't use the same setup for a drag racer and an off-road truck.
Perfect analogy. So manufacturers design dimple patterns to achieve different things. Higher launch, lower spin for pros maybe, more forgiveness, extra carry for amateurs.
So it's not just a matter of putting dimples on, it's a really detailed design process.
Oh, incredibly detailed. It involves a ton of R&D. We're talking sophisticated computer modeling like CFD, computational fluid dynamics.
Fancy simulations.
Yep. Plus, lots of wind tunnel testing, robots hitting balls over and over, analyzing the data.
Robots. Seriously.
Yeah, hitting robots provide consistency that humans just can't. They measure everything. Then engineers tweak all sorts of variables.
Like what kind of variables?
Oh, loads. The total number of dimples, for starters. Their shape, are they round, hexagonal, some other shape, how deep they are, how wide they are.
Depth makes a difference.
Huge difference. We'll get more into that. Also, the angle of the edges of the dimple, how they're arranged on the surface. It all matters.
Wow. Each little change affects how it flies.
Subtly, sometimes dramatically. It impacts the trajectory, how high the ball peaks, the spin rate, how far it carries, how much it rolls out. Everything.
And then they test these designs.
Rigorously. They make prototypes, often using special molds. Then they test them indoors, usually, with launch monitors tracking every detail.
Like the ones you see at golf shops.
Way more advanced, usually.
Yeah.
They capture launch angle, ball speed, spin rates, backspin, side spin carry distance, total distance. Just mountains of data.
And they just keep tweaking and testing.
Exactly. It's an iterative process.
Right.
Test, analyze, refine, test again. There's no magic formula, just painstaking work to find the pattern that achieves the specific goal for that particular ball model.
So it really is about tailoring the performance. You mentioned designing for different player types.
Absolutely. A manufacturer knows who they're targeting with a new ball. Let's say it's for very skilled players, low handicappers.
Right.
They might design a dimple pattern that promotes a more penetrating flight, maybe lower spin off the driver for control and distance, but still allows for high spin with wedges.
Right. Control is key for them.
Definitely. Whereas for a ball aimed at, say, a mid-handicap player, the priority might be different. Maybe they want a pattern that helps the ball launch higher easily and provides a bit more forgiveness, maximizing carry distance even on off-center hits.
Making the game a bit easier, helping get the ball airborne.
Precisely. So the dimple pattern becomes this crucial engineering tool to dial in those specific flight characteristics.
They call it the optimized dimple pattern for that ball.
That's the term, yeah.
Mhm.
Optimized for its intended purpose and player.
You mentioned dimple depth earlier as being really important. Can we dig into that a bit more? How critical is just the depth?
Oh, depth is one of the most critical factors. It's like a primary control knob for trajectory.
How so?
Well, generally speaking, deeper dimples tend to create a bit more drag, actually. But they also help the ball fly lower, a more piercing trajectory.
Lower, okay. And shallower.
Shallower dimples generally reduce drag a bit more and help the ball launch and fly higher. More hang time, more carry.
So there's a trade-off. You can't just make them super deep or super shallow.
Exactly. It's a very delicate balance. Go too deep, the ball might balloon up too much in certain conditions or just not have enough carry. Go too shallow, and it might not generate enough lift or might fall out of the sky too soon. You lose distance either way if you go too extreme.
It needs to be just right.
Just right for the intended flight. Engineers sometimes use the garden hose analogy.
The garden hose.
Yeah, think about watering your lawn. If you point the hose too low, the water hits the ground too soon. Point it too high, and it goes up but doesn't travel far forward. There's an optimal angle, right?
Yeah, that sweet spot where the water goes farthest.
Exactly. Engineers are doing the same thing with dimple depth, trying to find that sweet spot for the trajectory that maximizes total distance, both carry and roll, for that specific ball's design and target player.
That makes a lot of sense. The garden hose trajectory. So, okay, we've got all this complexity, number, shape, depth, arrangement. Does this mean that even balls that look kind of similar on the shelf might fly very differently?
Absolutely. That's a key takeaway. The overall pattern creates a unique aerodynamic fingerprint for each ball model.
A fingerprint.
Yeah. Think about, say, the Titleist Pro V1 and the Pro V1X. They're both premium balls, used by tons of pros. They look pretty similar sitting next to each other.
Right, both white, both dimpled.
But they're designed to perform differently. The Pro V1X, for instance, is generally designed to launch higher and spin a bit more, especially with the longer clubs, compared to the standard Pro V1.
And that difference isn't just because of what's inside the ball, like the core or the layers.
That's part of it, for sure. The internal construction, the core compression, the mantle layers plays a huge role. But the dimple pattern is also specifically different between those two models.
How different.
Things like the total dimple count, the specific layout pattern, and yes, the average depth and shapes of the dimples. They are tuned differently to help achieve those distinct flight characteristics.
So you couldn't just say, take the Pro V1 pattern and make the dimples deeper to match the Pro V1X flight.
No, it doesn't work like that, because the entire system of dimples on the Pro V1X is optimized for its intended higher flight. Changing just one variable, like depth, on a different pattern won't necessarily replicate the performance. The way the air flows over the whole ball is unique to that specific pattern.
It's the whole surface working together.
Exactly. It's a total system optimization, not just tweaking individual dimples in isolation.
Wow. So, okay, the next time you pick up a golf ball, it's worth taking a moment. Look at those dimples.
Yeah, definitely.
Realize that what looks simple is actually the result of, well, a huge amount of science, testing, physics, aerodynamics.
It really is. Reducing drag, optimizing lift, controlling the trajectory, those tiny little dents are doing a massive amount of work. They're not just decoration, they're critical performance enhancers.
And in a game like golf, where literally a yard or two can make the difference.
Oh, absolutely. Between winning and losing, making a cut, getting a personal best.
Every single element of the equipment matters, which kind of makes you wonder, doesn't it?
Wonder what?
What other seemingly small, insignificant design details are out there? In everyday objects all around us, things we barely notice, but that are secretly shaping how things work, how we interact with the world. How much difference do those hidden designs actually make?
That's a great thought to end on. Makes you look at everything a bit differently.